Hello. 1 year ago, I showed how to solve this problem. Now I'm going to show how to think to solve this problem. In the past, it was just a solution and nothing else. Now it will be explain the solution. Well, what can we see here first? Also, I solved it in near 40 minutes, if you would like to know. First, let's note that this thing is just word of this thing. The same thing with this stuff. But what to do with this word of x? Okay, I have one interesting idea. Let's try substitution of this root as a and this is b, for example. So now I finished it. What to do next? Let's try to compare, not compare, let's try to combine denominators to make numerator. We can do this. We will get ab, for example, and x. But wait, we'll get x in the one side and x squared of x. And we will get something interesting, right? Let's try to take off the denominator and use the common factor, common denominator, right? Okay, now we have common denominator. Yes, it is like a plus b, a minus b is a squared minus b squared. Yes, it is very interesting. But it won't work, because this stuff isn't the same. Okay, let's try to move our denominator upside in the right hand side and try to solve. But firstly, let's try to simplify it quite. No, we cannot simplify it, but we can open the brakes and then try to simplify. What is this? Okay, it is so large, but what's the second? I can see common number here, but it goes here. It won't be cancelled. But it's almost the same stuff like this. Okay, let's try to surround them. We surrounded them with different colors, and now we just cancel them all. Leave only this stuff. Well, we got it. Now let's try to look. We have something interesting. Square root of 3 here is common, and here square root of x is common. What can we see here? It is a times b, it is a plus b. But let me remember one interesting thing. A plus b squared is a squared plus b squared plus 2ab. It means we can try to make here square, for example. Well, why square? We have sum, we have product of multiplication, and square has the both. Square and sum, we will get sum and sum of squares, but sum of squares here is just x. Yes, it is x. My idea is very interesting. This idea will let us move here squares, and squares of this stuff will make full square. Well, substitution, and what can we get now? We got, but this is 2 over 2. It means we got a full square here. Yes, we got it. Almost. Sorry, wait a second. We got it here. Now let's try to divide by this stuff plus this. But wait, is it equal to 0 or it cannot be? Let's write it some another side. Yes, we made it, but why it can be never equal to 0? In the real numbers, it's very easy to solve. This is always bigger than 0. This is bigger than 0 too, or equal. It means oh sorry, forgot. One of them will be also bigger than 0, and another will be 0 or bigger. But let's think the second attempt. Complex numbers. In the complex numbers, it may be possible to get 0, but it isn't still. Why? Square root is just like absolute value, but not absolute value. Absolute value of square. Here we get something like complex space and real space, right? Sorry, excesses. For example, here we got something negative. Square from negative will be only on this side, which is I. This side is 1. Real, fully complex, right? And complex space. For example, here we got something negative, and here something positive. Positive will be here. Negative will be here. They both are to be equal 0 to make this equation workable. But it means they are to be equal to each other. X plus square root of 3 equals x minus square root of 3. It means square root of 3 equals minus square root of 3. It won't work. It will never work. It will be something like this. Can never be equal to 0. Okay, both can never be equal to 0. And also we thought it is not 0. But what about this? We have two square roots. Let's try to square it and get sum, which is just like x, and multiplication. Well, we got it. Now, if we were here in this 2, right? Let's divide it. Oops, we divided it. But why do we divide by x? I have an idea. Square, right? And squaring it is the final. To solve this problem, we will get x squared this side. If we will just like cancel x here, squaring it, we will get x squared here too. Just like here. Squaring both sides, we will get 36 over x squared plus x squared minus 12. X squared both sides. Yes, we got it. X squared, get it. But wait a second. X equals 2 is real solution, but x equals minus 2 will make complex solutions. Why? Okay, wait a second. You told me 2 is solution. Here we have something positive. The same thing everywhere it works. But minus 2, here we will get complex solution. Complex number. Here, complex number. Here we will get complex number 2. And here, as I remember, we will get the second. Yes, it is complex number 2. Everywhere here will be something complex. And here it will be 2 complex. It means in the real numbers, we have no x equals minus 2 a solution. Just note this, it is very important. Well, you solved it, and now you know how to solve problems like this. Maybe when you will meet it face to face, you will be able to solve it more better, right? Also, subscribe to this channel, set like, type any commentary if you want. Goodbye.